Hello guys, this is for IB, but IB math students who are doing logs, which is really good, but this also can be for math 30 students. So log base 3 of 2 minus 3x equals log base 9 of 6x squared minus 19x plus 2. Now let's just get rid of this. Now logs are defined, so log of x exists when it's greater than 0. Typically the graph will look like this at the vertical asymptote at x equals 0. So we can say that our x equals 2x minus 3. So we'll say 2 minus 3x must be greater than 0. Now we can just say 3x is greater than negative 2, my bad. X must be greater than, we take this to the side, must be greater than 2. Oh, x must be less than 2 over 3, sorry. That's one. Now the other one, you have to use the quadratic formula, so try that. Pause the video, try that. So I'm just going to say that, I'm just going to write this down, because I've already done this, so it's going to be 19 minus. If you got this, good job. If you didn't, it's whatever, try it again. You could also use a graphing calculator. So I'm going to rewrite this now, the right side, because they have different bases. Oh, shoot. Okay. I will explain this step later. Now how did I do that? Let's rewrite this. So we know that this is just saying, we know the log rule. Log a of b equals log b over log a. The basis can be whatever. Let's just say x, right? So let's try that. It's going to be log 6x squared minus 19x all over, I'll just write this in terms of 3. Log 3, guess what? Of 9. Well, that should be 9, sorry. This should be 9. Of 9. We can use the log exponent rule. Again, you should have the formula sheet with you. You can use log a of x equals x log a. That brings, so we can rewrite this as 3 squared. Comes here. Log 3 of 3 cancels, it turns 1 to 1. If you don't know why, put it into your calculator. You should be at the level where you understand this, but if not, log 3 of 3 equals 0. We're just saying 3 to the 0 equals 3. Or sorry, x. So this equals x. X, we're saying x equals 1. So the whole thing equals 1. Can I make this bigger? Okay, let's ignore that. So that should explain this. Control Z works, yes. Oops. Little. Okay. So that's how I get the 1/2. If you don't want to do that way, you can always remember that when you rewrite the when you rewrite the power, this is one identity you can use. Log. We'll just actually write this as a of y of x is going to equal 1 over y log a of x. You can try that, but the whole thing I showed you before is how you derive the identity. Now we have this. So we can put I'm going to put the exponent back, and the reason being is because when you have logs on both sides that are the same, you can take out the logs, right? That's another identity. So it's just going to be 2 minus 3x equals, this is the same thing as the square root, so I'll put this all in the square root. 6x squared, 19x plus 2. Now, I'm going to square everything. So we should be getting, let's write this. Again, FOIL this, right? Because we're squaring both sides. Should be 9x squared plus 12 no, sorry, that should be minus x. Minus all x. Sorry. 12x plus 4 equals 6x squared minus 19x plus 2. Now, let this equal 0, because this is a quadratic. I should get 3x, we'll just do it this way. I'm doing this differently, again, you should get the same thing. Or similar thing. This will just be 0. Oh, again, this is the negative, sorry. Right. Again, I just moved it to the right, moved it to the left. Should make sense. 6, 9, negative 3, negative 12, 19, negative 7 because we're adding. Minus, minus, negative 2. Sorry, minus, plus, negative 2. Now, we can use the quadratic formula, or we can factor. I will factor. If you use the quadratic formula, you'll still get the same thing. Now, I know it's 3, so this must be 3, and this must be x. Factors of 2 that add up to 7 are going to be plus 2. And can you guys guess the last one? Plus 1. Reason being is we have a 3 here. 3 times this is 2. This times x is 1. Actually, this time is 1, so 6 plus 1 is 7. Again, if you can't do that, just use decomposition. Decomp a quadratic formula. Formula. What the heck? You could also just graph it. So we're going to get this. Now we're just going to say 3x plus 1 equals 0, and x plus 2 equals 0. X equals negative 1 over 3, and x equals negative 2. Right? Let's go up. Let's see our restrictions that I erased by accident. So, yeah, one is this, where x is, less than, what was it? X must be less than, 2 over 3, negative 2 over 3, and it has to be greater than 19 minus root 313 over 12. This is a 19, by the way. Apologize. And both solutions fit that. So these are our answers. If you're asked to write this in ordered pairs, you can just do 1 over 3, 0, 2, 0. I prefer this, but this works the same. This is also perfectly fine. And that is our solution. So remember, decomposition for factoring your quadratic formula. Remember this new identity. Log. Oh shoot. And to derive that, did I show it up here? No, I didn't. To derive it again, it's just what is it? Log y over x. X goes in front, and then this just equals 1 over a log x to base 10 or whatever power. So we'll just say this is y. We'll just say x. Remember that, very useful. And again, when you have logs on both sides, they cancel out. When you're doing that, make sure the power's on the right, on the top, so it goes in with it. Because it's weird if it's just weird to do it like that. And then make sure you're collecting like terms properly, squaring it properly, and yeah, that's it. Hope this video helped. More will come in the future. Goodbye.